Okay, so let's draw the diagram. This is the slope. The angle is 8 degrees. That's actually a lot more than 8 degrees, but I always think it's a good idea to make it quite big, the angles on the sketch, so it just makes it easier to draw all the forces. So that's the caravan. This is the car, caravan, and car. And if we mark in all the forces, then let's do that in red. The car has a weight of 1,700 kilograms. So the mass is 1,700 kilograms. So the weight is 1,700 G. The caravan is 1,300 G. The weight going down there. The driving force on the car is 9,000 newtons. We're told it's going in this direction, up the slope. There will also be the resistances. So on the car, the resistive force is 600 newtons. On the caravan, the resistive force is 1,200 newtons. There'll be a tension here in the tow bar, and the last force, there'll be a normal contact force acting in that direction. Let's call this R1, let's call this R2. So I think that is all the forces drawn now. That diagram should help us to answer part 2. So in part 2, want to find the acceleration of the car and the caravan as they move up the hill. I think it's probably best to consider both the car and the caravan together, and we could draw another quick sketch of them both together. I probably don't have to do another sketch, but if we consider them both together, they'll have a total mass of 3,000 kilograms. So that's a weight of 3,000 G. The driving force is still 9,000 newtons. The total resistive forces would be 1,800 newtons, and that would be R1 plus R2. So we're still doing part 2 here. So if we resolve parallel to the slope in that direction, the resultant force equals MA as usual. So all the forces going up the slope is going up the slope, we've got 9,000 newtons going up. Going down the slope, we've got 1,800 newtons is the resistive force going down the slope, but we've also got this component of the weight here. So that component of the weight, don't forget this angle is going to be 8 degrees there. So this weight component parallel to the slope is going to be 300 G sine 8. So if we put that in here, we've got to take away that as well, so minus 300 G sine 8. and that's going to equal the total mass, which is 3,000 times the acceleration. Our G is 9.8 as usual, so if we type the whole left hand side into our calculator and then divide it by 3,000, we should end up with A as 1.0361 something. Let's just leave it as 1.036 because I think we're going to need it in the next question anyway, so leave it exact on your calculator. Find the tension in the coupling. You're going to need to either consider the caravan or the car separately. Okay, doesn't matter which. Let's do the caravan, since then we don't have to worry about this driving force as well, although it doesn't matter, you could do the car. Yeah, don't forget we know that the acceleration is this from the previous part of the question. So let's just look at the caravan. You could do another sketch. In fact, yeah, I think I will do another sketch. So 8 degrees here. Just thinking about the caravan this time. We've got the mass of the caravan is 1,300 kilograms. So the weight 1300 G. The tension is the only thing that's pulling it up, and the resistive forces are 1,200 newtons, and we've got R2 as the normal contact force. I think we're going to need to resolve parallel to the slope again. So once again, we're going to need this component of the weight. Again, that's 8 degrees there, and so this component of the weight, that will be 1,300 G sine 8. Okay, so let's resolve parallel to the slope again, this time just for the caravan. So as usual, resultant force equals MA. All the forces going up, well, there's only the tension going up. Going down, you've got the 1,200 newtons going down. You've also got this component of gravity, so that would be 1,300 G sine 8. The weight is 1,300, and we know the acceleration is 1.036 from the previous question. So you can move everything over to the right hand side except the tension, and if you use the exact value from the acceleration you used before, you should end up with the tension as being 4,320 newtons if you round to 3 significant figures.